Hello, College Algebra student. This video is for Chapter 3.1, Functions and Function Notation. So function is a very important concept in college algebra because the study of calculus is actually a study of function. So we would concentrate on developing this concept and also use whatever that we learn in Chapter 2 about equations as a tool to work on function. So what is function? Function is actually a relation. So what is a relation? A relation is a set of ordered pairs, such as example 1. I have a set. A set is a collection of elements, and in this case, the elements are each one of them is a ordered pair with a first component and a second component. So the set of all the first component is called domain. The set of all the second component, the first is domain, the second components of each ordered pairs is called the range. So in this particular case, this is a relation. We can give it a name as F or R or something, but basically it's a collection of a first number and a second number, and first number and second number, and first and second. So if you collect all the first together, oh gosh, this is 4. So it will be 1, 4, and -9. All this is domain. Collect all the second number, so it will be 5, -3, 0 will be range. If there's a repeat, you don't write it again. So if there is if there is another one that is, let's say 1 and then 0. So 1 is already there, so you don't write it. And 0 is already there, you don't write it. So it's just a list of all the pairs. What it means is 1 is related to 0. It's a relation. -9 is related to 0. 4 is related to -3, like that. And sometimes we say 1 maps to 0, -9 maps to 0, 4 maps to -3 by using a mapping diagram where we have all the sets of all, the domain on one side, like 1, 4, -3. This is the domain. And then this is the range. We just use a circle to contain all those elements. 5, -3, 0, and we say 1 maps to 5, so that you know there is a order. 1 is the first, and this is the second. 4 to -3, and 1 to 0. So if there is another one, 1 to 0, -9, this is actually -9, then I would just do another arrow. Okay, if there is one. So the second example is this ordered pairs is not necessarily finite. It could be infinitely many ordered pairs. So I can actually say this relation is a ordered pairs of x and y, where y is x plus 10. So whenever I define what x is, then I add 10. That would be my y. So there's tons of them. So you can say 0, 10, 1, 11, 2, 12, right? Or you can say 0.1, 10.1. So there's tons of them. So this is more a generic notation. We call it set builder notation. So in this case, domain is set of real number. That means any number you can put is x. Range is also a set of real number. You add 10, it's still a real number. So you could have a relation like that. Okay, so long as you can define what is x and what is y and how they're related, and that this is the description of how they're related, and that's a relation. And then what is a function? A function is a special types of relation where each element in the domain is assigned only one element in the range. So that means when you do the mapping diagram, for every element in the input x, this input domain, you can only have one arrow out. Okay, so this is a function. Although Q and R share the same output in the domain and the range, it's still a relation because the requirement is assign only one element in the range. Each one of them has one element. You don't have to have unique element. Just one is fine. So this is one where it is each one has their own element. They don't share. It is a function. So this is a function. This is a function. But C is not a function because when Q maps, it maps to 2. It maps to 2 different output. It is a relation but not a function. So remember, the first 2 are function. So in a more descriptive way, we say each input value maps to exactly 1 output value. You cannot map to 0 value. You have to map to 1 and exactly 1. More than 1 output can map to the same more than 1 input can map to the same output. So like this one, we say the output is the function of the input. So we use this word, output is the function of the input. It is related to the input by the function. So we can look at a set of order pair. Is this a function? So what we can do is we can actually just draw the mapping diagram. The easiest way is like that. 2 to 3, it is a mapping. I have only 1. 4 to 5, only 1. 6 to 3, only 1, right? They share the same one, but it's okay. But every single one that comes out only have 1 arrow, so it is a function. Is this table a function? Is x a function of y or y a function of x? Okay, let's see. Y is a function of x means xy. Okay, x, y. So if x is a function of y is a function of x, this means you do a diagram like this: 5, 2, 8, 4, 6, 1. Do I have 1? Everyone go to 1? Yes. Is x a function of y? So I'll do y here because it say a function of y, meaning this is the input of something. Of something is the input. So y would be 4, 6, 1, and x is 5, 2, 8. They are all 1 to 1, right? So it is also a function. So x is a function of y, y is also a function of x. So you need to know this kind of terminology. Most of the time we say y is a function of x when this is more common, right? More common. And for this arrangement where y depends on x, we say y is a function of x. This is the statement. And then we also restrict, you can see that there's actually 2 kinds of function where they share output or they don't share output, right? So let's look at if they don't share output, each input go to 1 unique output. We call it a one-to-one functions. It's a function where only 1 input value maps to each output value. It's a one-to-one function. And in 3.7, you'll discover that one-to-one function has some special properties because one-to-one function has something called inverse function. In 3.7, you will see this again. So that means there's no repeat x or y. For example, 2 go to 3, 4 go to 5, 6 go to 7. Each one of them had their own value. 4, 5, 6, 7. You won't have 6 go to 3 to share with 2. Okay, so this is one-to-one. There's no sharing. A function can not only be a order pairs or a formula like that where you generate the function, right? A function can also be represented by graph. So how do I know, how can a graph be a function? All the points on the graph will represent x maps to y. So if I have a graph that goes, you can have 2 types of graph where there's discrete. You only have dots, right? You can only have, this is a graph. You can have a graph like that. That is also a function. So there are numerous points on there. Tons and tons of points. For this, you would say, I read out the x value and I read off the y value. X will map to this y. This x, like maybe 2, will map to 4, right? The point, the coordinate here tells you x maps to what. Okay. And if there are lots of value, then you would say every single x on the graph will map to the corresponding points. How do I tell a function is a graph is a function? Because in the mapping diagram, I can actually draw the maps, right? So we have something called a vertical line test to see if a graph is a function. In that, if all vertical line cut the graph at one point, only one point, then it is a function. If there is a case where you cut at 2 points, so say for example, I have a function, I have a graph like this. This is not a function because I will draw this vertical line. It will cut 2 points. That means the same x, say for example, this is 2. It would go to 5 and it go to -2. So you would have 2 maps to 5 and -2 is not a function. So vertical line test. Check that all vertical line cut the graph at one point. And there is something called a horizontal line test. It is used to check if it is one-to-one. So you do a horizontal line, like this one is not a one-to-one because when you do a horizontal line test, they cut 3 points. A one-to-one function would be either always increasing or always decreasing. So when you do your horizontal line, you only cut 1 point. Very similar to the vertical line test. So this is one-to-one and also a function. Okay, so let's look at some example. Maybe I'll make it bigger because it looks very small. Is it too big? Okay, so this one. These 4 graphs determine if they are a function and determine if they are one-to-one function. So let's do vertical line test. So if I go vertical, there's only 1 point, right? So this is a function. Okay, but is it a one-to-one function? No, because I just draw a horizontal line and I have 4 points, so not one-to-one. What about this? Oh, this is vertical. If I draw here, I have 2 points, so it's not function. To be a function, it can only cut 1, right? And also obviously not one-to-one because when you do horizontal, you also have 2 points. 2, 1. About this one, so if I draw a vertical line, I always just cut 1, right? So this is an asymptote because it's 2 branches, it's the reciprocal function. I only have, so vertical line test okay, so it is a function. Is it a one-to-one function? If I draw horizontally, do I cut 2 times? No, I only cut it once. And then the branch here, I only cut this one, so also one-to-one. So this is the one where it is also a function and a one-to-one. The first one is only a function. How about this? If I cut vertical, I only get 1 point. If I get horizontal, I only get 1 point. So it's the same function as well as one-to-one. As one-to-one function. Horizontal line test is for one-to-one. Vertical line test is for function. And you have to be a function first before you can classify as one-to-one. So I think we'll do function notation in the next video.